Hey guys, it's Moth here. So today we are going to discuss a very interesting, famous Erudov question, Erudov 1.175. My main objective regarding taking this problem is to teach you a new approach to solve this kind of problem. Halaki, there are many other methods also, but my main focus is to teach you a new tricky method. Okay, so you could call this method as somewhat like a phasor method to solve collision problems. Okay, so this method helps in such type of question where you want to find the maximum deviation and all those stuff. Okay, so I will show 3 or 4 methods to solve this particular problem, and at the last I will show my tricky method. Okay, so let's go to the usual way of solving this kind of problems. Okay, so let's go to the wording of original wording of the problem. So here you are being asked a particle of mass m1 moving with velocity u alights another stationary particle m2 less than m1 obliquely and elastically. Calculate the maximum angle of deviation through which the striking particle may deviate. Okay, so your objective is to maximize this particular theta. So if you are new to this channel, pause and give it a fair attempt for about 5 to 10 minutes, then resume the video. So hope you have done. So let's go to the solution. So the first method is the vector method. Okay, let's go. So I have drawn a very rough diagram of the problem. There is a mass m1 with the moving with velocity u, and there is a m2 which is a stationary, which is initially stationary, and after that this m2 goes here and m1 goes here. Actually m1 is more heavier than m2. Don't mind the diagram. Okay, so a very rough diagram. So our objective in this problem is to maximize theta. Okay, so in this first method I'm taking the help of vector method. Okay, so by the conservation of linear momentum is conserved as there is no external forces. Okay, so here this is the before collision, this is after collision diagram. So before the collision only momentum is only the m1 mass has momentum, but after the collision both m2 has one also and m1 or both have momentum. So by the conservation of linear momentum, you could say initial momentum is equal to final momentum, and I'm taking this p1 to the other side and taking mod and square. Taking mod and square is an important method. You have seen in vectors also. Whenever you are locked in certain substances, most of the cases we take mod and square, right? So similarly, here also we are taking the mod and we are squaring here. Okay. So that's the first equation, p square plus p1 square minus 2p p1 cos theta is equal to p2 square. Hope this is readable for you, as I had written this by using mouse. So so the next, this is the first equation. Okay, so the next equation comes from the conservation of energy. Okay, so p square by 2m1 energy can also be written in this format also, right? Yeah, p square by 2m1 is equal to p1 square by 2m1 plus p2 square by 2m2. From this equation you could frame this out. p2 square is equal to p square minus p1 square by m2 by m1. I'm leaving the calculation part for you. It makes the video too lengthy also, so that I have already written all the steps for it. Now substituting this p2 here and simplifying this, you will get a quadratic. You will end up with a quadratic in p1. Okay, so this is the condition for having at least one root. Yeah, d is greater than or equal to 0, and putting this equation d square minus 4ac, you will end up with this containing 4 and p square from both sides. You will get cos square theta greater than 1 minus m2 by m1 whole square. So taking this m2 by m1 whole square on the other side and cos square theta to this side, will get sin square theta less than m2 by m1 whole square. Take into both sides, since both of them are positive quantities, so there is no issue of taking roots on both sides. Okay, sin theta less than m2 by m1, theta less than sin inverse m2 by m1. Okay, so the theta is less than or equal to sin inverse m2 by m1, so the maximum value of theta is sin inverse m2 by m1. So actually I have forgot to tell one thing. This theta is what? It is the angle between p and p1. Okay, so this is the p initial momentum of the particle m1, and this is p1 final momentum of particle m1, and this is final momentum of particle m2. So I'm taking p minus p1. So since we are taking here p1 minus, so you know how to take a negative of a vector, same magnitude, opposite direction. So you will end up with red arrow. Okay, so negative minus theta is 5. So sin theta is the same as sin phi, so there is no issue. Okay, so at last you will end up the same result, n equal to m2 by m1. Okay, so I generally recommend students should remember this formula, that is sin inverse m2 by m1. It might be helped in other question if it saves you a lot of time. Okay, so remember this kind of, that's it, that you simplifies your calculation. As you know, this result, it's a pretty standard result also. So theta is less than sin inverse m2 by m1. So that's the first method. Okay, stay tuned, I will post the next video very soon. Till that, bye.